Guys, today we're going to talk about representing the distributive property symbolically. So previously in class, we had talked about a hands-on way using area to help us understand the distributive property. Now we're going to use symbols, multiplication symbols, addition symbols, subtraction symbols, parentheses, things like that to help us represent the distributive property using those math symbols. And the I can statement we're working on is I can use the GCF to understand the distributive property. So by the time you get to quadrant 3, this is your goal, is to find the greatest common factor of the problem you're given and then rewrite it using the distributive property. And so in this video, we're going to talk about representing the distributive property symbolically, but also we're going to walk through quadrants 1 through 3 just to make sure we're all on the same page and we're good with what we've got going on. Okay, so let's start off by just thinking about multiplication. Okay, we have, 2 times 3. That's one way we write a multiplication problem, and we know that equals 6. Because what we're doing, or 3 times 2, which means I'm going to take 2 3 times. So basically what I'm saying here is I'm going to take 2. 1, 2, 3 times I'm going to take 2. Okay, 3 groups of 2. 2, 4, 6, that gives me 6. Now another way we represent multiplication is with this dot. And the nice thing about the dot is that when we use it, there's no confusion, especially when we get into algebra with, is that an X? Is it a multiplication symbol? What does that really mean? So that's another way to represent it. And again, it means 2 taken 3 times, or 3 groups of 2. So here's group 1, group 2, group 3, whoops, and that gives us 6. Another way we are going to represent multiplication, and this is the way we're going to use it in the distributive property, is with parentheses. So if I have parentheses around a number, I'm basically, all it means is that I am multiplying again. I am taking 2 3 times, or I need 3 groups of 2. So 1, 2, 3, I get 6. So 3 ways to represent multiplication. This way, you're really not going to use anymore. When we get into more advanced math and algebra skills, which the distributive property is helping us get there, we're going to use these 2 representations. So it's a good idea to get used to seeing, when you see parentheses, it means the same thing as that time sign. When you see that dot, it means the same thing as that time sign. Okay? All right, so let's take a deeper look at the distributive property using this symbol. So again, I'm going to start with 3. Okay, I'm going to take but inside the parentheses, which we know means multiplication, instead of having one number, I'm actually going to have 2 numbers. I'm going to have an addition problem in here. Okay, so what this is basically telling me now is I need 3 groups, of 2 plus 5. Now, many of you already are going, well, order of operations, that means the same thing as 3 times, well, 2 plus 5 is 7. So basically you're thinking, well, that's easy. That just means I'm going to take 7 3 times. 1, 2, 3. When I count up my beads here, I have 21. Okay, that's not always going to work for us when we get into algebra skills because these might not be numbers. One of these or both of these might be variables, and so we won't know their value. So using that is going to be maybe not the best method. So let's look at another way to look at this visually. 3 times 2 plus 5, okay? So all this is telling me is that I need to take 2 3 times and 5 3 times. I'm taking everything in here 3 times. So let's take 2 3 times. And let's take 5 3 times as well. And remember, 3 times 7, we looked at that. What's 3 times 7? It's 21. So let's look. 5, 10, 15, plus 2 is 17, plus 2 is 19, plus 2 is 21. So all that means when I've got these parentheses in here is multiplication, which means I am taking these numbers however many times we said. So really what I've got here is 3, when I take 3 times the quantity, 2 plus 5, what I'm really saying is 3 times 2 is 6, plus 3 times 5 is 15, which gives me 21. Okay, so it's the same thing as I would do when I'm using the order of, I would get the same answer if I were to use the order of operations. But again, I can't always use this because these might not be numbers anymore. We might move, we're going to be moving on. We might get some algebraic, when we get into algebraic expressions. So let's review how this relates to your quad work, okay? So for example, number 1, we looked at this. This is what we did in class together. When you go to rewrite this here, you're saying part 1 is this space in here, okay? And part 2, the second part here, would be this space in here, okay? So let's look at that. So here we go. What I really have here for part 1 is I'd have to figure out what 3 times 5 is. Now this is exactly what we just talked about with the distributive property symbolically. For this next part, I would need to do, well, the area here, I have a height of 3, a base of 10, so 3 times 10, okay? And you may even need to write underneath it what you've got there. 3 times 5 is 15, 3 times 10 is 30. When I add those up, my total is 45, okay? So really, there's a few ways that we represent the distributive property. What we did here, we really did 3 times 5 plus 10, because I took 5 3 times, and I took 10 3 times, okay? So this is one way we write the distributive property. Here's our second way when we expand it out. And then our third way is when we go ahead and start to solve it, okay? So 1, 2, 3. Each of these get us to this total of 45. So go ahead for number 2 and write this problem using the distributive property, and I want to see all 3 ways, okay? Pause the video and give it a shot. Okay, let's see how you did. So first we're going to do what's in here. Well, let's look first at what do we have here. We really have 4, so our first way is 4 times the quantity, 6 plus 5. That's what we're looking at here, okay? So to do that, part 1 is going to be the area of this rectangle, 4 times 6. Part 2 is the area of this rectangle, 4 times 5. And when I work that out, I know 4 times 6, this is my second method. Third one here, 4 times 6 is 24, plus 4 times 5, which is 20. And all together, when I add those up, 24 and 20, I get 44 as my total, okay? All right, so for quadrant 1, you're going to do this section, and so you're going to choose 5 problems from that section, but also problems from this section here, okay? This they've given you one way to write this using the distributive property. You're going to give actually two more ways. So what you're thinking here is 4 times 60 plus, because remember, I'm taking 60 4 times, but I'm also taking 3 4 times. So 4 times 3, which is 4 times 60 is 240, plus 4 times 3 is 12, okay? And you can go ahead and give the answer if you want, but I'm really looking for these two methods. So go ahead and pause the video and try number 20. Okay, let's see how you did. For number 20, you should have written 5 times 80 plus 5 times 4, because I'm taking 80 5 times and 4 5 times, which gives me 5 times 80 is 400, and 5 times 4 is 20. Okay? All right. Okay? Let's look at the next set of problems here. Here, now this is where the GCF comes in. What I'm going to do is I've got one way of using the distributive property. I need to get to this, okay? So to get there, I need to find a common factor of my two addends. And specifically, you're going to eventually want to be finding the greatest common factor. So for this section, I'm going to ask you to use the greatest common factor, okay? So the greatest common factor of 20 and 30, and you might need to work it off to the side, but it's 10. So what I'm thinking here is 10 times what gives me 20? 10 times 2. And 10 times what gives me 30? 10 times 3. So now I'm going to notice, what do these two multiplication problems have in common? Well, they both have a 10. So I can pull 10 out. So what I really have here is 10. What I'm actually going to do is I'm going to take 2 10 times, and I'm also going to take 3 10 times. So here's one way, using the distributive property. Here's my second way, now that I've pulled out my GCF of 10. And finally, my third way is to write it symbolically using the distributive property. Okay? Pause the video and give number 35 a shot. Okay, let's see how you did. I'm looking at 12 and 16, and I notice that they both have a GCF of 4. Okay, so that means I'm going to pull 4 out. Well, if I take 4 as a factor out of 12, what do I get? I get 4 times 3. If I pull a factor of 4 out of 16, I get 4 times 4. So what do these two multiplications have in common? What factors do they have in common? They both have a 4 in common. So I'm going to pull that out, and I'm going to take 4 times the problem. What's left? 3 plus 4, which means I take 3 4 times, and I'm taking 4 4 times. Okay? We are done with this video. You can go back and watch any part as many times as you need to, or the entire thing, but don't forget to WSQ in your notes. And have a good day.